Close my eyes and let it lift me up. Heavy clouds are moving, walking towards the coastline, looking like it's time to pack it up. Looking like it's time to pack it up. Colorado sunrise illuminates the tree line. Close my eyes and let it warm me up. The blue goes on forever, an empty page to write on. Breathe it in, it's time to fill it up.
Well, we're back. Let's see here. Let's turn down the music a little bit again. Something like that. Let's reset all the statistics. There we go. Right, we should be back. Is anyone here? That is the big question. We left with 118 viewers, and we currently have 32. You know. I guess we'll go to the face shot real quick. Is the YouTube chat working? It is not. Why not? Let me try that again. You can see me. That's good there, Fat Daddy. Oh, Kavik and Jadagun. Here we go again. More pink LEDs. Don't know about that yet, Johnny. Don't know about that yet. But I first need to fix my YouTube chat because it's not working. Oh, well, that didn't do it. Ah, there we go. There we go. 38 and counting. 38 what? Oh, 38. Oh, yeah, 42 viewers now. And already 8 likes. Very nice. Pink should be the standard for diff boards. Well, that's kind of a problem there, Jamie, because there is already a standard, and that's orange. So, yeah. Can't really go changing that now. Let me do this real quick. There we go. Okay, we should now have 60 frames per second. Focus on YouTube and let YouTube insert ads for you. No. Dismiss. Ultra. Well, I actually didn't drink my Pepsi. Oh, other way around. Pepsi Mango last time, so I still have it in the can. I put it back in the fridge, so we'll drink that in a minute or later or something like that. But we're still in the the pre-stream time, so as is normal, what are you guys drinking? I try to drink weird, funky Cokes. Just super chat an insane amount, and they will be pink. That's unfair, there, Johnny. Now you're trying to get those people to pay. Where did you find that Pepsi? I don't know. A friend of mine actually bought it. She bought a few of these things and gave them to me like, here, for during your live stream. Kevin Henry the 8th. Whoa. Just watched your stream earlier. First time seeing someone build a board. Hooked now. Nice. Oh, my monitor just rebooted. Okay, that's fine. Rivella Framboos. Ah, the original Coke. Sure, yeah. Limited edition pink. In NL? I am in NL. Oh, in NL. Yeah, I think she went to some kind of specialty shop. Oh, wait. Here we go. There is a tag on there. Seemingly it came from Snekje. So I'm guessing that's some kind of website or shop somewhere. I don't know. But a few of them she got were actually expired already, so you have to look out for that. Sure, no problem, Chardo. Oh, Philip comes in with a donation. Pink for Johnny and the rest. Best wishes for everyone for the new year. A bit early, but who knows when the next stream is. Well, maybe tomorrow, who knows. But it depends on how far we get today. Thanks, Philip. That's really appreciated. Any more birthday date cans? No, this one's... let's see here. Oh, this one is... 09/01/24. So... yeah, but we still need to finish it. I think the autofocus of the top cam is working pretty good now. At least I like it. It seems to do what I want it to do. Well, you know, since it's going to be a long stream anyway, let's just get started. So let's put these to the side. And this, and this, and then we need our utensils. So let's do two midpoint ones. Oh. And we're also going to do two midpoint twos, because I'm mostly interested in those, because those had the biggest changes. But we have to make everything to test it, so we're going to make everything. We don't start before there's more pink. Well, we don't start with putting on the LEDs, so there's still time. I guess I should set a amount then, huh? Let's say if there's more than 50 euros or dollars or whatever of donations in total, we'll do pink LEDs on this board again, on the midpoint 1. And then after that, it's again the same target for the midpoint 2. I mean, yeah, okay. I need this stencil. Oh, sorry about that. Right into the microphone too. I'm sorry. Okay. Next time I'll try and mute it. Okay, let's get started. Let's just do it. Do it. So, okay. Let's see. I'm gonna try something new. I'm gonna try putting my stencil like that instead of on the side, because then I'm not too bothered by the tape. How is that? I think it needs to go this way. Wow, this board looks kind of funky. It's the hassle. Should still do. Okay, let's try and line it up. No, wait a minute. No. Wrong order. We need to clamp it down first. Because otherwise it lining up doesn't do anything. Okay, now we line it up. Sorry, I know you guys can't see, but I need to see it well, because otherwise, well, it's not going to work. I think that's pretty well lined up. Yep, yeah, that looks good. Oh. Oh, Johnny Bergdahl comes in with 100 SEKs for the Pink LED Fund. Oh, and Draadstahl immediately counters that with 11 euros for Pink LEDs. But now I need to... how much SEKs do you need for €1? The entire workshop pink? Well, we can do that. That's the stretch goal. If we hit the goal, I'll turn all the lights in the shop pink. And put on pink LEDs also. €1 10 SEKs. Cool. So now we're up to what, 31? This is going pretty quickly. I guess I'll have to build another board to test the LED brightness. Because if this continues, we're going to be using pink LEDs all evening long. And the brightness differs per... oh no. The brightness differs per LED you use and the resistor value you use. So if you design it for pink LEDs, you use a different resistor value. Holy! Philip, what are you doing, man? What are you doing? €50 donation there by Philip. He's emptying the bank account just to get pink LEDs for Johnny. I guess he wants those late night texts again. Oh my god. Okay, let's first turn the studio pink. Hold on. Okay, let's disable there and disable my effect here, there, and disable my effect here. And go pink. Well, it's more bluish, isn't it? Well, I'm trying to find the best pink. We're gonna get a few different shades of pink. That's fine. Johnny Bergdahl's the pink judge. Well, there's only so much I can do. Let's see. Garage wall. Color 1. Is that pinkish? I guess it's pink. It doesn't do anything anymore, though. Let's put it on breathe. Does that do anything? Yeah. Oh, I know what we can do. We can do this one. Why isn't it working? Oh. Ah, there we go. Okay, I need to fix something. Hold on. Let's do it like that. Yeah. And then let's go to this, that, this. There we go. We have pink flames for Johnny. Pink flames for Johnny, always good. There, okay, a little bit less brightness. Yeah. Well, one of them is still a bit blue. Hold on. This is too blue. Can't do that. There, that's more pinkish. Okay, we need more pink here too. There. Now everything's nice and pink. Okay. Let's get back to the board. Hold on. Ah, my headphone cable's in the way. There. Okay, back to the board. So this seems pretty well strapped down. It's a little bit jumpy still, but that should be okay. So let's get the tools out. You may now proceed with the stream. Good. Thank you, Johnny. Oh, and thanks everyone who donated. I cannot spread holy paste with a screwdriver. Not that good. There. We smudge some on there. So now I taped it down differently. So now hopefully the tape isn't in the way of the squishing. So let's ball this up. To something like that. And let's go. Yeah, I think that did it. Let's have a look-ski. Yeah, that looks pretty good. I guess I should show it really close. There. Yep. That seems to have worked. Did I line it up incorrectly? I think so. Okay. Okay, let's do it again. One more time. That should be good. Yep, all pads seem to be hit. Uh-oh, okay, didn't touch it. Good. So let's now put it back into the holder. Okay. You can smell that stuff from here, yeah? This is a fresh pot, so it's pretty smelly still. That's fine. Oh wait, there was the thing in there, okay. Put that on the ground. Pink nail polish? No, 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 no. Let's not go crazy here. I think Quinder is ignoring us on purpose. Yeah, maybe, maybe. I would for sure die of the smell from nail polish, though. I certainly cannot handle that. Okay, good. He should dye his hair pink? No, we need a lot more donations for that. No, my beard, no, no. I don't want to. Okay, let's put this back over here. You see on the top one, the hassle finish is a lot rougher than on the bottom one. I'm not sure why that is. Still feel there could be a little bit more light. There, maybe that's better. Okay, let me find a BOM file. Oh, I think I already opened it. Yeah, now this is for the old one. Oh, maybe not. Okay. Midpoint 1 version. Yep, that's the correct version. And let's see here. And now I enable this guy, and I click here. I have so many clickings to do. There. We need to enhance. Is that readable? I think so. And I can place my components right here in this window. I guess I should... No, working on them side by side is harder. So what I'm going to do, since chat isn't that fast right now, I'm going to do it like this. Yeah, that should be good. Okay, back to the components. Capacitors, 402, yeah. I need 2, so I need 4. These boards have a lot less components, so that's easy. One day, can we get a workshop tour? Okay. Maybe. But the workshop isn't as big as you think. Because I'm touching the outer wall here. And now I'm touching the outer wall here. So I can touch it here. And then I can touch it here. So the workshop, it's not that big. Let me click a few buttons real quick. There. So yeah, you can get a tour, but it's really, I mean, you can't fit a second chair in here. It's not big enough. So, I mean, there's not much to tour. Oh, wait, no, I need to fix the orientation there. Because that's going to be confusing otherwise. Yeah, that's easier. Now I understand where everything goes. But your organization of components and stuff is interesting. Yeah, okay. Maybe at some point I'll do a video about that. In its current state, it isn't... it's what I can make work, I guess. And one over here. Get the orientation right. No, these are ceramic caps. It's okay. Okay, that's a good point, Johnny. That's a good point. I'll think about it. I'll think about it. Because most of the time it's also like kind of a crap. Because I'd rather work on stuff than tidy it up. So, yeah. Okay. A 10 UF 10 volts. 4.7. 4.7. 10, 10. Do I also have a 16? Wait, why is this here? This shouldn't go here. Okay, 10 UF 10 volts. What about factory tours? Factory tours are actually coming. because when I went to China, I did film a lot of stuff. But to be honest, I just didn't feel like editing those right now, because I wanted to work on this kind of stuff. So that's why we're getting this stuff. But next year, when I'm returning full force with the videos, there will be some videos about the production of QuinLED and the AllNet offices and things like that. Let's see here. Oh, more 0402s. .16V 1UF. Okay. Well, we've got 25. That's fine. When QuinLED-Diff? Well, when these prototypes work. But yeah, QuinLED-Diff Solo is currently in production. So those hopefully somewhere in the first weeks of the new year. And these are the more advanced boards, so they will come after that. Over there, okay. Let go, please. It doesn't want to stick in its place. Come on. Don't be like that. Holy shit, hold on. If they're all gonna act like this, that's gonna be a problem. Okay, cleaning the tip. Oh, come on. Okay, it's down. Now I need to correct it. Okay, good enough. I'm not going to touch it anymore. Spare diff in a car? What? I don't know. Let's see. That should be all capacitors. Yes. Or all 0402s. Well, normally it's not that much of a problem that the boards slide around, but this component didn't want to leave the smooth, warm home of the tweezers. Let's see, 2.2, 100 volts. Yep. Well, these are comparatively very big, so that's easy. There. And I believe that's all the SMD capacitors we need. Uh, 0402, 0402, 06, 06. So we need some 5.1K and 33R 0402s. I also bought QuinLED-Diff, not when. Oh, what? So, the QuinLED-Diff series, and there's going to be several boards and types and series you can get actually. They transform a LED data signal from a single-ended signal, which is very hard to run on longer lengths, and you have to deal with signal interference and things like that, into a differential signal, which uses 2 wires. And then you can easily run it for like 500 meters or something if you wanted to. So much further. And these boards transform the signal into a differential signal and then transform it back later. So basically you can get your LED data signals to go much further. Yeah, it's gonna solve some challenges you sometimes get when you need to do extra data connections further down the line and things like that. Okay, those are done. Wait, why did I put the box away? I need some 33Rs too. I have some plans for that, Robert, but it's not a feature I think everyone would use. So adding all the hardware to the boards, which is of course possible, would, well, or maybe not, depending on if I want to keep the same form factor or not, would also increase the price. So adding a feature that costs money, but then, for instance, 85% of the people wouldn't use, I'm not sure that's a wise move. But that's why we're building external boards first, so you can add on these to your setup. And after that, I will look into what is a good way to move forward with that. Let's see here, we need some 0603 resistors. Low. Yeah, these boards are add-on boards. So 220, no. 120, yes. And yeah, probably I'll add and create a specific DIG Octa board at some point. But I'm not sure yet how to proceed with the DIG Uno and DIG Quad. Maybe it'll be an AE Plus hat, for instance. Or maybe something like that. I'm not sure yet. Okay. Absolutely, Robert. Yeah. Okay. Well, it's SMD LED time. It just came up, so let's do it. Let's do it. Let's get some pink LEDs. People went crazy donating, so... Well, there's not going to be a diff solo with PoE, or well, not in that sense, but there will be the power diff series, and I've already done some live streams on that, and that is likely the same thing as you're mentioning. Where does that go? Over there. Okay. So that will be indeed a diff solo combined with power delivery. Wow, what is up with these tweezers? It's really annoying. There. Okay. The pink LEDs have landed. This is iBomb. It's an iBomb export from KiCad. Okay, let's get some diodes. Where do I have my diodes? Over here. Whoa. The last one? You mean the last revision of this board, or the board we built earlier today? Okay, diode's done. I need an LDO. SE. No. Earlier today, so the board we built earlier today was the sender 4, so that's going to send 4 channels, and this board is a receiver 1 midpoint. Well, let's send this anywhere, I guess. Hold on. So basically you link this board and the other board together. That's why we built the other board first. So the other board sends 4 channels of LED data over a UTP cable. And this board receives those 4 channels, and you can select one of the channels to strip off and form back to normal LED data and then use as an output. That's basically the gist of it. And we're going to do a midpoint 1 and a midpoint 2 today. This is the midpoint 1 for if you just need a simple extraction basically. And the midpoint 2 incorporates more things like better power handling, able to extract 2 channels, has power injection terminals, etc., etc. So it really depends on your needs which one you should use. Let's see, pin 1 is down here. Does that explain it, Russell? Okay, we need some level shifter. This might be in here. Cool. Not this one. This one. Okay. Let's go for the PTC. 1206, 1660 volts. Yep. There. And I think that is all the SMD components. Let's see here. This is through hole, through hole, through hole. Oh wait, no. The switches. We need the switches. That's a good question. Where are my switches? Did I put them down here? No. I have a box called PCB buttons and switches. Is it this one? I think so. Yeah. So we need 8. Oh wow. My own live streaming overview is showing me something very weird. One moment, please. Ah, okay, that's better. I was getting very weird data. Okay, so I guess now we have a choice on how to place them, but we're going to place them all with the switch pointing down. And my tweezer is stuck. There. Let me check here. It might be the lights on Peacock. It's my own schematics, of course, but in theory it's 4 pairs on which you put a data signal, so most likely it's compatible as a dumb receiver, or as a dumb sender receiver, yeah. Oh, Johnny's gonna hit the bars. No, we turned everything pink for you, Johnny. And Leon Voss says data 2 in, 2 out. For the receiver 2, well, it's actually 4 in, 4 out, unless you strip one off and terminate it. But I'll explain that more in tomorrow's testing video. Yeah, they also use RS485. That is correct. Yeah, so they might very well be compatible. I just don't know. Okay. Yeah, for sure. But in theory, I think they are. I just haven't tested it yet. Let's see. Let's get the microscope out and do some checks to see if it all lines up correctly. there. Le Microscope. Oh, turn on power. Okay, I'm going to turn the bomb off. There. And let's see how this all lines up. Yeah, so this one is the one I bodged because it just did not want to stay in place. And there's a little bit low on solder paste there, but I think it'll still reflow. Let's see here. That should be okay. This one will not be. That's fine. That's fine. Okay, that's fine. Sure. Nothing really there. Okay. Okay. Falcom also does some power. What kind of power? That looks good. Oh. There. Okay, that's fine. Yep. Okay, that looks. Oh, that all looks good. Yeah, it's a good idea actually. I should test it myself too, but during prototype development, I at least have not yet. So let's get the heat plate back. Okay, oh, well, let me turn off the microscope. Let's turn this one on. There. Well, I guess I can put them closer together. There. Yeah, that's the idea. Lights on Peacock. It's to build a versatile add-on system for these, and then maybe I'll integrate them in current controllers or future controllers and stuff like that. But I first wanted to do the add-on boards so that people have options, whatever they're running, to basically be able to add it onto their setup if they want or need it. And also, maybe they want 3 channels local and only 1 channel remotely, or they do want a linking option and things like that. Making it all modular looked like the best approach to me. Ah, Leon. Okay, so I have a different series called the Power Diff series that I'm also developing, and that will also do power. I've already done some live streams about it, and I have some prototypes, but that will do about 100 watts up to 50 meters or so. We're already at 100 degrees. Yeah, exactly. That's the whole reason I'm developing this, so that if they run into that, they can either use a diff solo for a single port, or they can use this diff advanced, as I'm going to call it, for up to 4 ports, and then there's some advanced features there. Not just for data, but also at the remote end, you still need a board to distribute and fuse your power, level shifters, and things like that. And one of these things, for instance, is one of the advanced features these boards have is that they're compatible up to 55 volt. So they are compatible with the newer 48 volt puck style LEDs we've been seeing this year. This series will be immediately compatible with those. That's all looking pretty good. Okay, other board. Here we have an issue. Okay, that looks pretty good to me. Anyone see an issue? This is a Mechanic ET10. It's a 10 centimeter by 10 centimeter hot plate. It has been heavily modified though, because the original heating elements gave out, and I replaced those during one of my live streams, in which I had frequent power cuts, but you'll have to watch that live stream for that. So now currently it does 300 watts and it works great. But it's a pretty decent hot plate to start with. So if you're looking for a hot plate, look for the, I think it's in my equipment guide, and the equipment guide is linked in the video description. Okay, let's turn the power off again. I'm going to put this in my closet to cool down. There. And let's do a quick inspection. That is still very hot. So these look good. Let's see over here. Yeah, so this pad I had an issue with. So there's a little bit, it's a bit anemic in regards to paste. But I still think it's soldered correctly, so that's fine. This is slightly crooked, but that's still going to be fine. I mean, this pad here isn't great, but it's making contact, so it shouldn't really matter. Those look fine. That's fine. This could have flowed a bit better, but it's okay. Yeah, okay, so that board's fine. This board over here. All good. See, these will look a lot better. It's a lot better soldered. This one's also on straight. That's good. That looks fine. Sure. Yeah. That's flowed properly. Yeah. Okay. That all looks great, I think. Did anyone spot a mistake somewhere? I mean, these are pretty simple, so. Okay. Oh, 60 FPS goodness. Okay, let's turn the microscope off for now. On the second component next to the RS chip on the second board. Oh, I don't know which one. I don't even... It's just a bowl or soldered... Is oh, okay. Let me turn it back on. Hold on. So let's take another look. Music is a little bit loud, isn't it? There. Did you mean this board? I don't know. Oh, you mean this guy? It's not loose. Let's look at it from another orientation. Yeah, it didn't, where am I? There. It didn't really soak up into the pad here. But it's not loose. But I'll hit it with the soldering iron real quick and then that should be fine. Yeah, exactly, Mark. Yeah. Okay. So then let's continue with the soldering iron. Okay. Jesus. Okay. Yeah, exactly, Philip. What do I want to do first? I think the pin headers. Now, where would I have put my pin headers? Oh. Normally they should be in here. one extra line. Just not looking straight again. Okay, so let's try and, oh wait, still on the microscope. Yeah. Let's try and get these in there. Yeah, it's not really going to matter. Interesting view, that microscope. I like it. It's a good microscope. Oh wait, I don't have my suction. I need the suction tool. Hold on. Oh, you mean like that, the microscope? Yeah. There. Hello. Okay, so we soldered one of the pins, but it's completely crooked and misaligned. See? I mean, so what we'll do is we'll basically hold it to the board and then tap it. And that allows it to go in straight. See if I got all the angles. Yeah. Good enough, good enough. No, don't solder it together. I bridged it. Might need to add some flux here. There, that did it. Okay. It's not great, but it'll do. Okay, so we did our 2 pin headers. Where's my mouse? There. Okay, we need some screw terminals. Well, I need some more cable. Oh, that's right. That's a good one, Philip. But I really should get some flux for that. I still, again, don't remember which one it was. It's this one. It's this one. Let's see if I can tap it without flux, and otherwise we'll add some flux. Okay, need to add some solder to my tip. Yeah, it's not great, but it improved somewhat. Can I show you like this? I don't know actually. No. Yeah, I tapped it. It's a little bit better. Can you still hear me okay over that noise of the fan? Let's see here. Screw terminals. If not, we'll see some smoke finally. Maybe, maybe. Who knows? Oh, that was too loud. What did you say? Exactly. Let's get some RJ45 sockets. And we need some big capacitors. 220, 330. Oh, it's all just not on the screen. Sorry. It's because I ran out of room here a little bit. Oh, let me try and scoot this over. There, now you can actually see what I'm doing. So we got some big capacitors. We got some RJ45 sockets. We got these screw terminals here. Let's see if they have the right orientation. They do. And on this one also. Yep. What is higher, the screw terminal or the socket? The screw terminal's higher, so we can put the sockets in. And they should snap in place also on this board. There. Oh, the music doesn't play anymore, yeah. And these are special sockets with the lip on the top side and not on the bottom side, because I just like that more. Let's see, capacitor. Okay, height-wise that's pretty good. But capacitor has to go last because it's the highest. Okay. And we need a through-hole PTC to function as a fuse. Because for these boards, I'm thinking of not using a fuse holder, because I cannot use a fuse holder if I want to make them 50 volt or 48 volt compatible. So we'll use some of these PTCs. And the board has basically been first double screw terminals backwards, let's see. These are correct. And these are also correct. Yeah. So these PTCs, why 3? Well, if you look at the footprint, I can add a fuse holder here. That would work. But I can also add a 60 volt PTC here. And now it's 5 amp. And if I add a second one... Oh, now it can do 10 amp. So I'm going to make one with 10 amp and one with 3 amps. And see... or one with 5 amp and one with 10 amps. And see if that performs well, and I can deliver the boards that way. So I could make 5 amp and 10 amp versions, basically. Oh, this is a different one. Okay. There. No problem, Jamie. Rather you call it out and you're wrong, then we miss it and I can't fix it anymore. But these are definitely the highest thing on the board. Let's put the capacitor in here real quick. Yeah, they're definitely the highest point on the board. So we'll do those last. Capacitor second last. And this we might be able to just solder by flipping it upside down. Like so. You want to see mistakes. Yeah, but I want these things to work in the end. Okay, so let's solder one of the terminals of each. Okay. This music is making me sleepy. Yeah, I left OBS on, so we're a lot further in the playlist than we'd normally be. So we're hearing some new music. That's actually fun. Okay, so let's see if I can correct these a little bit. Okay. Yep, those are straight. So let's do it with the other one too. Switch playlist. No, other music will come in this playlist. We've just never been this far into the playlist. Okay, that also... yeah, that looks good. So let's solder it up. This is a ground pad. There it goes. Okay. Yep, that's all good. Oh, it's focused on my my iron. Let's focus over here, shall we? There. Sounds like a song for the Droomvlucht at the Efteling. Nice. Okay, those are now on. Good. I guess we can solder the RJ45 pads or contacts. Okay. Yeah, I need to change the focus setting real quick. Oh, it is already on what I want it to be. Yeah, not much I can do there. I could draw the focus area somewhere else. There. Okay, that should be all good. Yeah, those stupid little pin headers weren't the worst. There we go. Okay, good. Change your iron. What? I like using the big iron tip. Yeah, it's just like Philip says, it's not always easy for us either, but practice certainly helps. Again, these stupid pin headers here. There. Let's take a look at that. That's fine. Yep, that looks pretty good. Okay, oh wait, we still need the caps and the PTC. Oh well. Yeah, see, this is a giant ground plane, so it's hard to get soldered correctly. Okay. That's it, should be okay. And okay. I'm soldering at 380, but I like using that huge tip to make sure there's a lot of heat transfer there. Yeah, let's do the PTCs. So one board is going to be a 5 amp board. I already noticed a design issue here, maybe. Let's put it in the outer slot. Let's do it like that. Yep. Okay. And you can always bend, if you think, oh, this is on straight, you can always bend it a little bit. So that's one done. We only need to snip off some leads. Yeah, so I would have rather had this had slightly more distance. So I need to see if I can maybe move that cap somehow. It's okay as is, but yeah. Let's see here. Okay. Exactly, Jamie. That's my reasoning for that. This might be a little bit too close. Now, normally the PTC shouldn't get that hot unless it's closed, and then it'll get 125 degrees. And that is, of course, these are 105 rated caps, but it'll just shorten the lifespan. Now, in a normal situation, that should, of course, never happen. So I need to think about if that's important or not. I don't know. I'll have to see. So now the soldering is really done for this board. We're going to do another board after this. I need to find my snips. Hold on. Okay. So let's take these leads off. Wow. There was a giant explosion just now. And normally you'd be like, what the hell is going on? But it's likely just fireworks. Okay. That's pretty good. Yep. One moment. I need to get rid of those cuttings. Okay. Okay, let's take a little break here. Well, sorry. Let's take a little break and take a sip of my Coke Mango. I'm really interested by now. Been looking at it for hours. A bus blade type fuse? Or what kind of fuse do you mean, Jamie? Because it needs to be handle 55 volts. Because that's the problem. Even I could put a normal fuse socket on there, that'll fit. But the problem is those fuses don't really support above 32 volts. And these boards will all be 48 volts compatible. So that limits the type of fuses you can use, because the fuse needs to be able to support 48 volts. Or rather 50 volts or 55 volts. Right? And I like using the auto reset fuses in that sense. No problem there, Detached Garage. I didn't have a lot of time to dive into it, but you know, just keep us updated, and we'll talk about it. So yeah, boards. Whoa. Now, we're not going to do an LED test right now. Maybe later tonight still, but we'll see. But we are going to do a power test. There is a small red heart there. Avari Chenroth. That is fully correct. Okay. Well, oh, you can't even see what I'm doing. So we have a little thing here called VCC in. That looks like, you know, what we should connect to. And then a ground next to that. I can look at glass fuses, but generally they're a lot bigger. And some height isn't a problem, but width and such is. Why isn't this working? Because I'm not opening it far enough. No, we're actually just going to test it. So if there's going to be smoke, it's going to be now. No, Jamie can't use that one either, because that's 30 volts maximum. And then I'd need 2 to 4. Because it's only 3 amps, and I wanted to be able to deliver it with 5 or 10 amps, because 5 amps is for an edge injection, and 10 amps is for a mid injection. Okay. Ground black. VCC in red. Good. All the switches are off. That's fine. Okay. Let's wait. Stupid cable. There. Let's turn on the power supply. No, other one. That's okay. Now fuses have a voltage rating, and those are very important. And once I kind of need a 60 volt rating on the fuse for this board, because if I limit it to 24 volts, we could use our regular style fuses or a much smaller PTC or something like that. But since I want to make it 48 volt compatible, we can't basically. Oh. And for instance, the Diff Solo, so this guy over here, that one is limited to 24 volts. So there I can just put a fuse socket on there and done. But for this guy, to be able to support a higher voltages, you can't. So yeah. Let's see here, 5 volts, let's set it to 0.25 amps. Lean back and go. Nothing happens. Did I do something wrong? Could be that the LED is reversed, of course. So when I hit power, it doesn't draw anything. So let's check power is actually there. Yeah, we are getting 5 volt in. Okay. So let's check here, and then on the PTC fuse over here, 5 volt. 5 volt. Then let's check on this pin. Oh, also 5 volt, good. Yep, 4.9, that's good. Then I think the switches are off. Yeah, no, the switches can be off, that's fine. No pink LED, exactly, that's the problem. So I think we need to reverse that LED. Which sucks. But, you know, because otherwise the board is working fine. And we're getting our voltages wherever we need them, so... Higher voltage means more headache. Yeah. So let's go to diode mode and check real quick. In theory, I should be able to put this on ground, like so, and then hit the LED. Is my theory wrong? Okay, so I can get it to light up. Did I do it wrong? Interesting. I might have actually. Okay, let's reverse it. Okay. Test the other one. What? Oh, probes are on top of each other. Well, sure, I can test it quickly, but it'll have the same result because I did it exactly the same way. In theory. I'll do it jack style. I'll just hold the hold it on there. Wait, let me push this down. This is the way to do it. Oh wait, this one does work. So then I messed one up. Let's try it real quick. Yeah, seemingly I just messed one up. Okay, that's fine. Let's try and turn that one around. Who recommended trying the other one anyway? That was a good call. Okay, let's see. 220, that's fine. Oh man, that's gonna suck. Okay. Sorry, I'm really doing this with the wrong hand, so I need to do this off camera. Okay, it's off. I think I got it. The heart is annoying? Okay. I'll look at removing it sometime then. Okay, it's turned around and all components are still stuck to the board. We'll do a quick test because now the board is very hot, of course. Yep, that fixed it. Good. Okay, so now we have two boards that power up. Let's move on to the next boards, shall we? And we have to start this whole process all over again. Yay, pink, yeah. Well, it's a diode, so it probably won't actually fill up. Okay, let's get the last set of boards. So these are quite a bit bigger. And I'm using terminals on these that I've never used before, so that's interesting too. I hope they fit. Okay, let's see here. The heart needs to be pink. Oh, is that the problem? Okay. I think I want to do it like this. How does the stencil look? Yeah. Okay, stencil goes on like that. No, these are not the final colors. These are just cheap green because they're prototypes. I don't know, Philip. I don't know. Let's see here. Okay. Let's stick it down well. Slightly lifting off the stencil, but I should be able to fix that when pushing it down with the tool. Yep, that should do it. Oh man. Ye of little faith. Oh, okay. How long have we been going? Oh, we've been going 2 hours already. Jesus Christ. Sorry for my swearing. Holy moly. Okay. So let's finish these boards and then probably the rest is going to be tomorrow. But, yep, we'll see. So let's get a good amount of paste. Okay. Okay, that looks like a neat layers like that. I think most pads are okay except down here. No, that's okay. Okay. Let's get the second board in there. There. Okay. Okay. And this bowing isn't nice, but it'll have to do for now. I'm going to go over it one more time. Yep, that should have done it. Magic smoke's not good for business, but it is entertaining. Yeah, that's true. Well, we had some real magic smoke like a few streams back on the power diff boards where I, blew stuff up. Okay, second board pasted. Now let's get the paste back into the tub. Good. Clean up time. Oh. Too late for the pink smoke. Okay. Okay. Thanks for the donation there, Ovi Björknes. Not sure I should read that out loud on YouTube. The YouTube overlords might not like it. Wow, there's a lot left on here. Okay. Put it back in place so it stays nice and straight. Okay, don't need this, don't need this. Is that a dad joke? Thanks for the donation there, Ovi. That is appreciated. Okay, let's put this here. Bam. Okay. Now let's find a BOM file for that. Let me show you guys. So most of the stuff is down here. So I don't think I need to put it over here because there's only 2 diodes there, and we'll see that when it happens. So I'm going to keep it like that, and then I'm also going to turn these like that. There, that should be easiest. Of course, now the donation is there, it'll go away. I guess Fat Daddy knows all about dad jokes. Haha. Okay, well, we're starting all over again. Wait, I need to get some wires out of the way. I need to get... Okay. Yep, okay. 0402 capacitor. Capacitor. And we need 4, so we need 8. Okay. This is a 4-layer board. The Diff Solos are 2-layer, but the Diff Advanced are 4-layer. And that's mostly for power integrity, or power delivery, and also signal integrity. Okay, I think those are in the right place. Let's see, 1 UF. Let's cut this off. Wrong placement under D4. Okay, I already wondered if I made a mistake, but let me check it. Hold on. Because I am getting a little bit tired. No, just getting tired. So let's see. It should be over here and over here. That's correct. Over here and over here. That's correct. Okay. Then we have one. Wow, it's really starting to rain. Can you guys hear that? We shouldn't have it over here. This one's wrong. Wow, it's really raining. Yep, now it's correct. Wow, okay. Yeah, oh, okay. I need a 1 UF. No, this is rain. True, Philip, true, but it's raining over here. Okay. Raining is knuskwind. Yeah, sure. Maybe not if it's going this fast or hard, but sure. Over there. Okay. Over there. No, I'm confused. Okay. That could be. Yeah. Okay. I need to add a note. Oh, it's a local Quindor cloud. Okay, that's ticked off. Oh, whoa, oh, lightning now too. Oh, and thunder. Uh-oh. Oh, I need an 0603 capacitor. Okay. That's odd. Is it odd? Yeah, it is odd. Let me make a note. Make it before the storm hits your house! Yes, I'm trying. Okay. Minus 15 outside. Oh my god. No, it's like 8 or 5 to 10 degrees outside here. It's okay. It's already dying down, it sounds like. Let's see, 1206. That is probably in my stack over here. Oh, not so much. Oh, you had some two MSX toys? Well, I guess they now reach my place. My place is near Den Bosch. So... Oh, really? I thought that was fixed because others have done so and worked fine. But welcome, unexpected maker. I know they fixed the smiley bug at least. Hier ook Den Bosch valt geen druppel. Well, I'm near Rosmalen, near the Maas, so. Okay, that should be all the SMD capacitors. So we'll go to SMD resistors. Well, Happy New Year and good Christmas and holidays and all those things to you too there, Sian. Let's see, resistors. Low? Yeah, I think low. $5.1K. 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The stream becomes a weather update channel. No problem there, Danny. I'll have to look into that again, what that could be, but as far as I'm aware, all the chat settings are fully open and available, and yeah. Oh, there is more rain. Just flipping resistors here. There we go. Okay. It goes over here. Oh no, one's gone. Okay. Yup, the rain is back. Let's see, over there, and over there. Okay. Yeah, it's a bit thundery. Okay, and now I lost one, so I only have one here, but that's fine. That one goes here. Thank you for the $20 there, ZipClick Zen. Funds to keep the lights on during the storm. Happy early New Year, and thanks from me for all the videos. Thank you very much for that. That is greatly appreciated. Honestly. And it does actually help keep the lights on. So, you know. Because there's some kind of battery project where I need to build more on, but work more on, but you know, LEDs. Okay, let's see. These are done. Did I do them on both? Yes. Okay, 33R. Rosmalen Romper. Didn't hear a single thunder. That's just weird. Yeah. Any updated ETA on your custom analog CCT board being released? Yes. I have been working on that again this week. And again, made some progress, which I think is good. I found a new component which solves some of my issues I was having. Or rather, wasn't really an issue, but I wanted it to work differently, and it didn't. And now, because I found a component in a different footprint, I can make it work as I initially wanted it to. I know that's very cryptic. Wait, why did I didn't get enough resistors. So I updated all the boards again, and I've been working on that. Yeah, but cases is still a thing. But we should make some progress on that soon, I hope. They are coming for sure. It takes a lot of work to get a product launched. I mean, you'd think it just make a board and then it's, oh look, here's the board, that's it, done. Yeah. The design of the board is only half the work, in my opinion. Maybe even less than half the work. Okay, those are done. How will these QuinLED-Diff be integrated and used with the current QuinLED products? Well, these versions are all add-ons. So if you want one or a few lines further away than, like, let's say 10 meters, you can add on one of these diff boards, take one of the digital channels from the QuinLED controllers, and just send it on its way, and then you can have an independent power supply on the other end. So currently these are all add-ons for the current ecosystem, and then once those are out, I will evaluate where I might slot in an integrated board into the ecosystem, basically. Okay, let's see, 120R 0603. Do I still have 0402s? No. Uh-oh. Did the connection break? Nope. 120R 0603. Oops, no, wrong bag. Okay, let's put those in their places. there. Let's get some diodes. And we need 8 of those. You have stutters. I have 0 drop frames. Since I upgraded to fiber, it's been pretty good. I had 44 rendering and encoding lags out of 1 million something packets, so that can't really be it either. Is anyone else having stutters in 1440p? Unexpected maker. Takes so much work to get a product launched, right? People are like, why don't you just launch a gazillion products? Because holy shit. It takes so much time. Because you need documentation, you need photos, everything needs to be tested. It actually needs to work. The website, packaging, especially if there's a case involved. Casing is a bitch. Sorry for my English. Yeah. And that's just, I mean, then we're not even talking about getting them produced, because you have to do a trial run, and then you do testing again, and you optimize the manufacturing process, and there's design for current, and design for function, and design for looks, and design for manufacturing is the same thing altogether again. So maybe something might look cool, or it slots together that way, but it's horrible to manufacture, or you get too many errors during manufacturing, and you have to change the board layout again, and also cost savings. I mean, you can design it in multiple ways, and some ways are more expensive than other ways, right? But there's a lot of hidden stuff. But for the analog boards, the technical things are mostly done, although I'm again making changes now. But we've been mostly stuck on the cases. Getting a case manufacturer involved and having to do custom stuff with them, and going through several examples, prototypes, making changes to that, making sure they understand what you actually want. Yeah, I don't have a lot of software involved, but you, of course, also have some code there that you need, Sion. Absolutely. Okay, we did the 8 diodes. Now, I'll be kind, and I'll do some more pink LEDs. Even though Johnny isn't here, I am pretty certain he's going to go back and check the stream if we did more pink LEDs. And this is thanks to Philip, who donated for the Pink LED Fund. Actually, no. We will do 1 pink LED and 1 orange, because I need to check the brightness of the LED once it's on the board in the current circuit. And I can't do that if we make them all pink, because the end version isn't going to be pink. So, yeah. Johnny went to the bars while we are here slaving away at pink LEDs. It's just not fair, man. Let's see where these power LEDs are. Over there. Okay. Okay, so I want the green stripe to be over there. Okay. There. Why not make the pink version, the end version pink as well? Because I normally use orange power LEDs, except for on the Dig2Go actually. And I don't really want to deviate from that standard. Let's get some level shifters. Auction pink LED boards. I don't know about that. There. Level shifters done. The Johnny edition. To pay for his intervention to stop going to bars during live streams. They would be twice the price. What? Yeah, and they would have this really bright pink LED. Because, you know. RS485. Oh, same box. Uh-oh. Okay. Let's cut this tape a bit. Oh, over here. Let's turn on first pin mode. There. Saw they have TVs in bars. Just the screen on one of those big... What? Hey, Erik de Groot. So we can do a little bit in Dutch. What am I building? No, wait, that's English. Wat ben ik aan het bouwen? Ik ben een bordje aan het bouwen waarbij je een LED-signaal kunt nemen. Die zelfs met mijn bordjes niet echt veel verder dan 10 meter kunnen gaan. En die verandert dat signaal in een RS485 signaal. En daarna kun je ongeveer, nou laten we zeggen 500 meter ver komen met datzelfde signaal. En daar vorm je dat weer terug naar een normaal LED-signaal. En dan kun je daarmee je LED-strip aansturen. En dan hoef je je dus niet meer zo zorgen te maken over hoe lang je datasignaal is. In principe. En dit zijn prototypes die we aan het bouwen zijn. En als die goed zijn, dan daar kan ik allerlei metingen en testen mee doen. En daarna kunnen ze uiteindelijk ooit in productie. There, that's enough Dutch for today, I think. It screws up our brains. This sounds weird. No problem, Eric. Okay, so we need some LDOs. Did I put them back? Did I not? I put them back. Okay. Brabants accent. Yes, definitely. It kills my ears. Okay, I'll try keep talking Dutch. No, English. Wait. Maybe I could talk steenkolen Engels, because then people can understand me better and know I am from the Netherlands. How is that? You know, the Netherlands, also known as Holland, because we are near the rivieren. So yes. How do you like my English if I talk it like a normal Dutch person? You think my English is very good? Thank you. Okay, sorry, I'll stop that. Oh man, when I hear people, like official government people talking English on TV, I'm like, oh my god, what happened? Why are you like this? Okay, sorry. There, we have two LDOs. I think we need some PTCs. Yeah, that's a big one. That's a smaller one, yes. I just threw up a little inside my mouth. Van Gaal steenkolen Engel. Exactly. Oh man, it's so bad. It's just so bad. I can't understand how you can be that bad when it's like part of your official function. But, you know, it still happens. They're there. They exist. Nice, that was fun. That woke me up a little bit. That's good. I got to laugh. Oh man. Okay. PTC goes over here. Gotta have those fuses, man. Gotta have those fuses. Merry Christmas! And then I think we're going to add the switches. Which hot plate do you use for your SMD? Well, let me get it real quick because it's cooled down now. I use a... There. I use a... No, alright, yeah, there. A Mechanic ET10. But it's, as you can maybe see over here, it's kind of heavily modified because I used it so much that the heating elements inside kind of burned up. So they didn't work anymore, or not as well. So I replaced those, and now it's a 300 watt, 10 by 10 centimeter powerhouse. It heats up in like 1 minute or so. Switches, yes. Did I put those back? Don't think so. Buttons and switches. Yeah, it draws 300 watts from the wall. But I also improved the design a little bit, because normally they don't have any thermal paste in there. So although it works, of course, the heat transfer isn't ideal, and if the heating elements are in free air and they can't really disperse their heat very well, it's all less efficient and they burn up and stuff like that. So I squished them in there with thermal paste, and we broke the house circuit a few times. But in the end, it's working great. So we're going to do... Oh, wait. I need to put it back on the desk. Hey. We're going to do switches down again. Oh, no, I got the wrong switches. These, I think these will actually fit. Let me check. They should fit. Okay, I thought these would fit, but they don't actually. Interesting. Well, I'll look at that some other time. I'll get the right switches. Oh, ooh. We need a matrix panel stream with fireworks? I don't know. Okay. Let's see here. I think we now have most, or rather all SMD components. No, we're doing heat plates. Heat plate. I only use the hot air to fix things nowadays. Yeah, that's through a hole, through a hole, through a hole. Okay, so next up is inspection by microscope. So I'll need to get the microscope up here if I can. Yes. Oh, still on. Good. Let's go to the microscope view. And I will turn off the bomb. There. So let's see here. We'll go over this one first. Okay. That'll straighten itself out. Stripes are in the right place. Okay. That's not gonna work. Okay. And we have some diodes here. Where are they? There. Stripes are in the right place. That's good. What are the things under the switches? Under the switches? Oh, you mean this guy? Yeah. But that'll straighten out. That shouldn't be a problem. And a cap on top too. Okay. No, these caps should be fine. That'll straighten out. I'm streaming with OBS. Yep. Not the Streamlabs, just the normal open source OBS. Okay, so that's board number 1. I think that'll be fine. Let's check the PTC here. Oh, we didn't check the PTC over here, huh? That's fine. That's all fine. Yeah. The cap on top too for the LDO. Yeah. As long as it's touching, it'll auto-correct that. But there. Just like the PTC, it's a little bit crooked, but, you know. That should autocorrect. That's fine. Let's look at the same here. That's all good. Good. This is not hitting both pads. There. Same here. Okay. This could be better. Yeah, those caps look like a mess too, but that'll be fine. Switches look good. Oh, I didn't look at the switches on the other one. This doesn't look great. Okay. Back over here. That looks fine. That looks fine. Sure. Diodes are on correctly. Oh. I think that'll work. I think the LEDs are in the correct orientation, but we'll see once it's soldered. Okay, we're just gonna do it. We'll correct during reflow. Okay. Okay, on. So let's get these on here. Oh no, I hit the switch. I need to correct this switch here, hold on. Good enough. Okay. We are currently at 49 degrees. This is, where did I put it? Whoa. Let's focus it. Chick Quick TS391LT50, but it's a LED-less that doesn't need refrigeration or cleaning, and it's it doesn't actually say, does it? Yeah, 391 LT50, but it's 138 degrees paste because I use it for prototyping, so that if I later have to correct something, I don't have to blast it with 500 degrees. I can just blast it with 200 degrees and then fix the component. Odido is down. Oh no. Did you switch from Tweak to Odido? Because I didn't like Odido, so I went to Glossnet. Let's see. 107. Okay, well the can is on the ground. T-Mobile. Oh, yeah, well, I know Odido used to be T-Mobile, but okay. I don't like their internet stuffs. And I've been streaming for 2 hours and 50 minutes, and we had 0 network drops, so that's good. Okay, we're at 130. It says smoking. Can you see the smoke? I don't think so. Oh yeah, you can see the smoke a little bit. Maybe if I do this, I don't know. But that's just the flux, so that's good. We're almost at 150. So I'm gonna start checking stuff with my magnifying glass real quick. I'm going to touch some stuff. Okay, that all looks good to me. What do you guys think? Any glaring issues? I don't think so. The board, okay, the boards are not pink enough. That's not an issue I can correct right now. Okay, let's have those cool down. Let's take away the heat plate. Haas is that different than Home Assistant, or I run Home Assistant for everything. Let's see, Microscope. So let's give that a check. So this is the top board, PTC. Let's check those diodes real quick. Yeah, those are good. The LDO, the cap, okay. Yeah, okay, old name for Home Assistant. Yeah. Okay, that all looks fine. Yeah, okay. Yeah, I'd say this board looks great. Let's check the switches. Switches are all good. Let's move on to the next board. Let's go to over here. That's fine. Let's check the yeah, okay. LDO looks good. Level shifter looks good. This LED is a bit crooked, but it's stuck on there, so that's fine. Let's see, switches. Switches are all good. Again, level shifter, caps and stuff. Yeah. I think that all looks great. I really like this microscope. I mean, come on. You can like, oh look, there's a little dot there on my finger. Oh wait. Okay, I can't do it with this side. Okay. It's really insane the amount of magnification you can get and overview at the same time. So you can get a good overview, or you can get like crazy magnification. So you can actually see the scratches on the hassle, or if you wanted to see those legs individually, that works fine. And you can see the top part and the bottom part, and then you can also do it like that, and you can instantly see the whole board. Love it. Still need to make a video about this one, because of all the microscopes I've tried and I've bought in the past, this is certainly the best one. This microscope camera array is from AliExpress, yeah. Okay, but we don't need the microscope anymore. So we're... 4K! Yeah, my cable is 4K. Well, the microscope's 4K too. It says it right here. But it's actually, I haven't been able to... Where did I go? Okay, I haven't been able to get it into 60 FPS mode at 1080p, but... I'm going to put the microscope away now. One moment. Turn off? Yes, no, maybe? Oh no, I turned it back on. Okay, I'll just hit the socket. There. You bought the lens, forgot to order the camera portion. Oh, okay. That's gonna suck. Yeah, I still need to add a little bit better lighting, but I have the components for that now, and then I'll do a video about it because I really like it. It's good, and it's not that expensive. It's not cheap, but it's not that expensive. And yeah, I also really like my new camera setup that I improved at the end of the year. That's also been working great, and I like the 60 FPS at 4K, so that's all good. Although this one I need to mount down lower so I can get something bigger in the screen. Oh, you thought the lens was the price for the whole thing? Yeah, yeah. More lighting or a bigger desk? Is it still too dull? I think it's because it's too far away. I can lower the whole arm, but yeah. Then it gets harder to do overviews. Although, with the lens I have on there now, I can get an overview like this, which is pretty good, I think. Right? And then I can go all the way down like that. And that's the nice thing about this lens. It's f4 over the whole range. So no matter what I change in regards to the zoom level, the lighting will always stay the same. Yeah, oh yeah, I have some, because I only have a ring light on the microscope right now, but I want to add some of those gooseneck lights, and that should make it even better to spot certain, certain bumps and stuff like that. But I have the stuff for that now, I just need to do it. Maybe, I know, when I take a little bit off at the beginning of the year. Okay, let's see, can we have suction? Yes. Okay, let's get some RJ45s. No, my desk lighting is actually pretty good. There's like 100 watts there. We didn't realize we are here for a short and big fire show. Well, it wasn't short. We're already streaming 3 hours, and I did 2.5 hours before. So, I mean... Oh, no. Let's not put these in here. I am going to gather all the components, though. 2 330s per board. Okay, and then I need some pin headers. For the microscope? Yeah, hold on just a second. Whoa. Let's see here. Oh, you got the rain. It took a while. Why isn't it logging in? Well, that sucks. One moment, please. Yeah, I don't know what my username is. Normally Google does this for me. Sign in. There. Okay. Let's see. Microscope. There, that should be the microscope, and I got the kit where it has the ring light, the lens, and the camera, and then separately you have to buy the stand, and the stand is this one. And well, it's not the cheapest microscope, of course, but it does give you a pretty good 4K image, as you've just seen. And what kind of suction? What? And yeah, the resolution is pretty good, and I like that it has the varifocal lens. That makes things so much easier. I do not have any suction equipment. I have a desoldering gun, if that's what you mean, but I rarely use it. Right, so we need PTCs. A little bit of rain, yeah. So 2, 3, 2, 3, 2, 3, 3. That's a few bucks in PTCs alone. And then we have the, okay, then we need the terminals. Whoa. Some boxes just fell over. Hold on. It's okay. It's okay. I don't think it messed with my sorting, but we'll see some other time. Terminals. Oh, I have. Okay, I didn't understand that one. I have this guy. Hold on. It's the Aten ST1016. Says 16 watt with a filter in the back. And all the fumes are sucked through there. So that at least, you know, cleans it up a little bit. Okay, large terminals. And I'm excited to try these because I haven't tried them yet. No, wrong ones. Those are the right ones. Yes. So I need 2, 4, 6, 8. How are they spaced? Does that work? No. I need only 2. Yeah, keep them posted on Discord, Weston. We always love to see, so let's see if this is going to work. Yes. Oh, wait, you can't even see. One moment. There. I'm just adding terminals to make sure I have enough. Oh, let me check that real quick. One moment. No. I got the 50mm stand and the 120X full kit. I need to make a note. Oh yeah, we're still going. Still going strong. The 180, oh my. Yeah, that's even more, so... in my opinion, the 120 gives you the best range, and, yeah. Okay. So let's get all these PTCs out of the way. We have all the terminals here, but those are likely the highest point. So let's get those out of the way. And I think we need to start with the pin headers here. And it's raining again. Yeah, it was tight getting these, damn it. It was tight getting these pin headers in there. But I managed to tweak the design. I think we're going to do the turnaround trick. Otherwise we can use a little bit of tape. But okay, let's do one board first. It's a bit of a big board. There. Let's tack on one of those pins. Some nice action on Bioradar. Yeah, I bet. Okay, let's take a look how that looks. Huh. That's actually not too bad. Sure, I'll solder them in that way. Okay, next one, we'll do the same trick. It's literally a marathon soldering day. Yeah, absolutely. So this one is on fine. Like that one. This one needs to be pushed down a little bit. So let's try that. Yeah, that's okay. Let's solder the other legs. It's not great, but it'll do. Let's try and get this to go away. Sure, that'll do. Okay, let me refresh something real quick. So next would be, I think, the small 2P. Need to go to BedZoom, test out my new bedroom TV. Oh, that sounds nice. Let's do these real quick. Yeah, that looks to be pretty good. Okay, let's get the other one. What? 65-inch in the bedroom? We have a 65-inch in the living room. Okay, that works out good. So, what is next, you think? I think it's the RJ45 sockets, but those just snap in, so... Oh, I love that snap! Oh, this one didn't snap as loud. Hold on. What? No. Doesn't want to go in. Why not? Oh, there we go. Let's try one last time. Ah! Satisfying. Yes. Okay, but we don't need to solder those because those snap in tightly. So let's see. Maybe the capacitors. Oh, we didn't even get this terminal yet. Okay. No, let's get that terminal. Can you explain how to learn how to build microcontrollers? I want to learn how to build some, but also want to understand the meaning behind it. So how do you learn it? Microcontrollers themselves? It's not as good as the button of the Dig2Go, yeah. I think you mean electronics more so. They're about the same height. So for electronics, it's just a lot of reading, and there's some good YouTube videos out there which will help you with the design and what you need to take into account and look out for and stuff like that. And then it's a lot of reading and thinking. Especially like you first select components for what you want them to do, and then you read their data sheets to see what they actually do and how they respond and what kind of passives they maybe need and how they work together with other components and things like that. Because it's, you know, it's a question of mating together the right components to make it do what you want it to do, either as its intended function or as a different function than intended, but still. Yeah, it's a bit of a broad subject there. Yeah, I use a different footprint where I can select different capacitors if I want to, for either prototyping or actually also in production. Because, you know, prices, especially the last few years, fluctuate. So if I can have it incorporated in the footprint that I can easily change it out, I'll do that. So then, you know, it doesn't need a design change. Later, Weston. So yeah, it's partly for prototyping and partly for production reasons. So let's solder one leg of each of these things. Oh no, that's the wrong leg. Okay, that's fine. Oh, what YouTube channels would I recommend? That's a tough one. I wouldn't be able to say. There's a what's his name again? Let me look up his name or the channel. So, for instance, Microtype Engineering is a good one. He makes some nice stuff and nice videos about designing electronics. What's his name? I know he had a video a few days ago, so I'm scrolling through my subscriptions. Let me look for a keyword here. Yeah, Phil's Lab. Phil's Lab also makes some excellent videos guiding you through component selection and schematics and things like that. So Microtype Engineering and Phil's Lab are certainly good channels, although, you know, they might be a bit advanced, but they can help you figure some stuff out, I think, in their videos. Don't ask them directly, but... No problem there, Christoph. Yeah, Big Clive is also nice if you want to understand more about circuits and things like that. But he is a bit more random in the things he does. It's fun to watch, but the other channels are better in regards to doing a whole project and thinking of the schematics yourself and things like that. Thanks for the kind comments there, Christoph. So, let's see. Okay, that's all pretty decently straight. Yeah, did we make it round on the playlist? It's possible. Yep, happy with that. Did I orient the capacitors correctly? I think so. Oh, this board's still hot. Okay, let's put those away. Right, so things we need are PTCs and screw terminals. Yeah, I figured the text wouldn't be readable anymore. But that's not too big of an issue. Yeah, we really did go round in the playlist. That's not too big of an issue. Because it's also always on the back, right? So, I mean, I get text on the front is better, but I'd have to widen the board. Maybe I could widen the board a little bit. Yeah, maybe I'll widen the board by a few millimeters so you can see the text properly still. Then again, once you've used the board, you should know what everything does, but you know. Okay, let's see with a PTC in here. What is going to be the highest? The PTC is highest, so we do the terminals first. That is funny, but I left it on during the break, so that's likely why we went round on the playlist. Yeah, these are all giant planes. Okay. This one's fine. Well, also not perfect. Let's do it. Ow, that's hot. There. Oh, the rain is back. Okay, that should do it. Oh, I didn't slide these together properly, I guess. Okay, that is fixed, but now this one is still... Ow, 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 ow. There's so much ground plane in here that if I try and fix that terminal, the whole board heats up. But that's good enough for now. And the screw hole clears, that's good. Because these are again all custom footprints, so... Might need to adjust the holes slightly because they're a bit big, but... No, these will be a challenge. It's pretty good. There. The rain is back in full force. Yeah, I'll need to fix that silk screen because I just need a few millimeters more, I think. Okay. Better do it now than later. Hold on. Add a note. Yes. How long have we been going? 3.5 hours. Oh my god. Oh my god. So remember, do not solder them down fully. Oh wow, the rain is really going now. So this one we just tack in here a little bit, like that. Okay. Again, this one's fine. Oh, this one's pretty good too, I think. Yeah. Can you guys hear it? Good night, everyone. Getting awfully late over here. Good night there, Christian. There was talks of flooding over the past few days over near here and near the rivers and stuff like that. But I can't imagine this rain helping with that. Yeah, it's pooping, yeah. Okay. Popping, yeah. Pooping, yeah. It's pooping rain, I don't know. Fine with me. Okay. So now we have terminals, and we just need to add some PTCs. We can go straight through the testing stream. Yeah, I don't know, man. My energy is running out at some point. So on here I have designators for 10 amp and 5 amp. So the 10 amps get 2 PTCs. And the 5 amps get 1. Okay. Not sure how I'm going to position this. Maybe something like this. I don't know. That's probably going to be really wobbly. Yeah. I will just solder one of the legs. So for LED lighting, you really want to use a 5 amp fuse for an edge injection, and then a 10 amp fuse for a middle injection. Because that way, you've basically fused it for its intended purpose, and it shouldn't really ever use more than that. So this board versus the Power 1 does a lot in regards to power injection and distribution and fusing. So if you're, for instance, running 5 volt LEDs at that spot, and you know you want some more power distribution and fusing and things like that, well, this board has that built in. Well, with the midpoint 1, you would have to do that yourself. Later, Philip. So let's see here. Let's bend these. Oh, let's bend these a little bit so they're not touching. It's okay if they're touching, but if they don't have to, I like that better. Look at that. Very nice. Okay, let's solder the other legs. There. That looks pretty good, doesn't it? They're also pretty close to the capacitor here. I guess I could move them slightly to the left. Let me make a note of that. Move capacitors. You need some blue tack. Keeps it still. Yeah, I have some of it somewhere, I think, but generally I manage. Okay, let's do this again. Okay, let's try and position these a little bit. It probably, if it's a new TV, I mean, I don't think you can get TVs that aren't smart TVs nowadays. Wait, can you even see anything? Oh, sorry about that. There. Okay. So let's straighten these out a little bit. There, that looks pretty good. Okay. Nice. That should be all soldering done. We only have 69 viewers. Oh, now we have 70. Oh, the RJ40. You're absolutely correct there, Hilbert. Can you tell I'm getting a bit tired? So let's snip these off and do the RJ45s. You are also getting tired? Yeah. Okay, let's do the RJ45s. Let's get rid of this snipped off stuff. Good. RJ45s. Well, this isn't a great position to put this in, is it? Oh well. Let's see if I can do this somehow. There. That should do. Hard is in the way. Yeah, I'll look at how I can remove that some other time. When does the QuinBox Part 2 come out? What are you talking about? Okay. It's 0.6. I think I have another roll here. One moment. And it's this stuff. Sometimes you can find it on AliExpress, but it's from Best, 0.6 millimeter with 2.25% flux, and it's 6040, so it's just normal leaded solder. It's just it just solders better. Oh, no, I still have lots more packages, but I don't want to swarm everyone with QuinBox all the time. Well, now we have a soldered up screw hole. Let me make sure it's clear at least. There. You like QuinBox? Cool. Okay. Well, there's more coming. No worries there. Let me try and clear that hole a little bit more. There. I think. Only making it worse. Okay. This one seems done. Yep, that should work. Nothing better to get some Coke and chips and watching you with the wrong snipping tools to unbox Ali stuff. Where do you leave all that stuff from unboxing? You have more garage space at the neighbors? I wish. We are actually running out of space. As I already mentioned, this office is actually pretty tiny. So yeah, space is actually an issue. Oh, made a bridge. There, unbridged it. Yes on both there, Michael. And when will they be available? The Diff Solo will be available first, since this is still in the prototyping stage. And I'm hoping that will be somewhere in the first weeks of January. And then these will follow later, and then Power Diff will follow after that. And controllers with more ports, I have some plans, but I'm not sure if and when I'm going to work on those yet. So, can't say too much there. Later, Nigel. So, that was a long session, but I think we made it. Because this looks good. Right? Can still get to the switches. Move these around a little bit. I know these don't look that great. Like fuse holders on there looks better, but this should still work great. But that's why I built the prototypes, because we're going to test that. Yep. So, let's apply power, and then today's live stream will be over. So here it says, oh wait, no, let's move this away. There. Here it says ground. So that's ground, and this is the positive side. It also says it down there, VCC, ground. And since these are these nice terminals, we can just hook them up. If I didn't wreck them completely. Oh, my monitor's going to stand by. Don't do that. I did kind of wreck these completely, huh? So let's bend them back a little bit. This is the best fork. There. No problem. Well, actually, I'm missing a lot of wind energy currently, because that's what it's originally been built for. But yeah, it's kind of on the back burner right now. For several reasons, but I will get back to it at some point. Thank you for the marathon sessions. No problem there, Glenn. So, this looks good, right? These always twist a little bit there. Yeah, this is always going to be a thing. I'm not sure about this yet. Releasing a product with these actually on there. But if I want to make a more than 24 volt version, I don't have a choice. So, yeah. Okay. Let's see here. 5 volts, 0.25 amps. Did we do this correctly? Yes. Okay, let's lean back. Oh, we got a pink LED immediately. And it's almost drawing no current, so that's good. Okay, so that seems to be working. Sure, Christopher. Normal LED data signals have a hard time getting far away. So with my normal boards and the data booster and stuff like that, you can get up to 10 meters generally without a problem. But the signal itself is kind of weak and not very immune to outside interference. So what these boards do, they take a LED data signal and they form it into another type of signal, a differential signal, and that can easily go 500 meters. So then you're not bothered by interference and things like that, and you can move your data signal to wherever you want. So you can keep your controller inside, for instance, and I don't know, your prop or your LED strip can go wherever it goes, and you can easily get your signal there. So these then have a local power supply, and that local power supply does not need to match in voltage. So even though your DIG quad, for instance, or DIG octa is running on 5 volt or 12 volt for channels close by, you can then hook up one of the diff sender boards, and then on the receiver board you can put 48 volt LEDs or 24 or 12 or whatever, and that won't matter, and all be compatible with each other. Yeah, so a normal data cable can only be so long, and with these you can make them very long. 500 meters, so half a kilometer or whatever. Yeah, they have. So Merlin asks if the resettable fuses also have other advantages next to being resettable. So yeah, there is the resettable part, of course, so you don't ever have to change the fuse. But what it also does is it enables a higher voltage, because the normal blade style fuses, they top out at 32 volts, and these can go up to 60 volts. That's also why they're so big. But yeah. Okay, let's try this one. Lean back. Uh-oh. Nothing happened. Did I do it wrong? No. Wow, is this LED on backwards? Are you kidding me? Okay, we're gonna do some measurements. DC voltage. Yeah, I like my the Victron stuff is really cool. So yeah, I'm not sure I'm gonna make a controller with only these outputs, but future controllers might include some of these outputs. So yeah. So let's see here. We need. Oh. This. And then let's apply power and see if 5 volt is being made. Yeah, so we are getting 5 volt. Are we getting 5 volt here? Yes. Good. Okay. So that likely means I put the LED on backwards again. Why do I do that? Okay. I am going to try and reverse this LED, but I have to do it off camera. So, one moment, please. Okay. I think that did it. I guess I can show you up close. Nope, doesn't want to. So I reversed the LED over there. Oh, can't show you. Fine. Let's see if that did it. Yep. Nice. Nice and orange. Not too bright. Good. No power usage. That's good. Excellent. That means these boards are also done. Well, we'll do more testing on them tomorrow. But, yeah. Oh, you figured, yeah, the fuse holder might be able to handle 500 volts. But the fuses, like those standard blade fuses I use in all my other boards, like these guys. I think it'll actually say it on there. Yeah, there we go. 32 volts. See that over there? Yeah, so 32 volts, that's not 48 volts. Eindhoven on the Zee. What? Okay, well, that was a 4-hour stream, and we already did a 2.5-hour stream earlier this day. Oh man, I'm beat. Thanks there, Jamie. Yeah, I'll be off to bed not too late too, because it's already 1 o'clock over here. So, yeah. If I have time, I think so, we will test these things tomorrow afternoon, evening. I think in the evening. He almost needs to snorkel. Exactly, Dutch Taurus. Yeah, but you don't want to, count on tolerances or something like that. You want a fuse that is rated for the voltage you're going to use. And it's only for the 48 volt port. Otherwise, if you put a fuse socket on there, you can just use those normal fuses. So maybe I'll sell 2 versions, who knows? Right? Because the 48 volt part is still kind of niche. So maybe I'll sell a version which has the normal fuse sockets on there, and then a special version which has these PTCs on there. But I don't know about that yet. So, yeah. What time? I don't know yet. Probably 8 or 9-ish, just like my normal streaming time on Fridays. Just like this stream started, basically. And then we'll test the... where are they? We'll test the 2 sender boards we made. Oh, wait. We'll test the 2 sender boards we made. Right? And then we'll also test the midpoint 1 boards. And the cool thing is about these boards, what's been added since the last prototype, is these pin headers for a jumper. And having a jumper on there means that it's terminated, and not having the jumper means it's not terminated. So in theory, and we're going to test that tomorrow, you can send out a single data signal from here, let's say on pair 1. It goes into this board, you take off pair 1, so that comes out of the LED output here, but then you daisy change it to this board, you also take off pair 1, and you still don't terminate it. You then take this board, you also enable pair 1, you daisy chain it again, and then you also take off pair 1 over here, and now you have 4 LED strips doing exactly the same thing. Oh, and we do put a terminator on here then. Yeah, because you have to terminate it somewhere. But in theory, you can expand the signal to multiple boards. They would do exactly the same, but maybe in some scenarios that would be a cool feature to have, right? And of course, if you want them to do all something different, you can just select pair. I don't know. I want pair 3 over here. And then you get pair 3. And then you put on a termination resistor. Right? So, that's never been tested. I just designed this. I'm like, yeah. In theory, it should work. But in practice, we'll know tomorrow. And, for funsies, we'll also short circuit some of these PTCs and reverse polarity them and stuff like that. See what happens. But that should all work okay. Yep. So tomorrow, we're going to play with LEDs. Thanks for watching, guys. I'm getting out of here. I'm going to sit on the couch and drink a cold glass of fris, soda, I guess. And not do anything else today. Okay. Bye-bye, guys. Draadstaal comes in with the €11 donation again. Thanks a lot, man. That's appreciated.